To attempt question like this, the first thing to do is to write out the chemical equation showing the reaction between anhydrous sodium trioxocarbonate 4 and excess acid. Though the acid used here isn't mentioned, we're making use of hydrochloric acid. So we're having the chemical equation showing the reaction between anhydrous sodium trioxocarbonate 4 and hydrochloric acid. So when this reacts, we have sodium chloride, water, and carbon dioxide as the products. Looking at the equation above, you can discover that the equation is not balanced yet. So to balance that, we'll be adding 2 here as a coefficient. So this makes sodium balanced. Then for chlorine, we'll come here to hydrochloric acid to add 2 as well. So with this, we now have a balanced chemical equation. And from the equation, we are to determine the volume of carbon dioxide or carbon dioxide that will be produced at s.t.p. And we are given the information that is about anhydrous sodium trioxocarbonate 4. We know the molarity and we know the volume that reacted, but we do not know the volume of carbon dioxide that will be produced at s.t.p. So in that case, we'll be dealing with anhydrous sodium trioxocarbonate 4 and carbon dioxide. So from the equation above, we can say that 1 mole of anhydrous sodium trioxocarbonate 4 will yield 1 mole of carbon dioxide at s.t.p. We need to determine the moles of anhydrous sodium trioxocarbonate 4 according to the information to the data given in the question above. Then with that, we can determine the moles of carbon dioxide and proceed to calculate the volume that will be produced at s.t.p. So let's proceed. To get the number of moles of anhydrous sodium trioxocarbonate 4, we'll be using the formula that says molarity equals moles over volume. So if the volume is in dm cube, we'll go ahead to apply it like that. But if it is in centimeter cube, we'll be multiplying by 1000. That is, we are converting dm cube, which is the standard unit, to centimeter cube. And from there, we'll make moles the subject. Let's do that now. So making moles the subject here. Let's not forget that the volume is given in centimeter cube. If the volume is being given in dm cube, we do not need 1000 for conversion in our calculation here. So the moles of sodium trioxocarbonate 4 will be equal to the molarity, which is 0.1 molar, multiplied by the volume in centimeter cube, that is 10, divided by 1000. Calculating this, we have 0.001 moles. According to the equation above, the stoichiometric equation above, we can conclude that 1 mole of sodium trioxocarbonate 4 will yield 1 mole of carbon dioxide. And if we now have 0.001 moles of sodium trioxocarbonate 4, how many moles of carbon dioxide will be yielded? We can conclude that 0.001 moles of carbon dioxide will be produced as well. That is because the ratio in which they are combining is 1:1. But if we have 1 here and that of CO2 or any other compound is different, if they are not having same number of moles in the equation above, then we need to go through the steps and show our workings. But in this case, we can just conclude that 0.001 moles of carbon dioxide will be produced as well. In our previous videos on questions like this, we show the steps of determining the moles of the other substance as well. But here we just move to the next steps by to calculate the volume of carbon dioxide produced, making use of the moles that we've got in here. Now to calculate the volume, we'll be making use of the formula that says moles equals volume over amount at s.t.p. And since we are dealing with volume, we'll be making volume the subject. The amount of gas at s.t.p is 22.4 dm cube. So volume of CO2, that is carbon dioxide, will then be equal to the moles we've gotten, that is 0.001, multiplied by the amount at s.t.p, which is 22.4. Calculating this, we have 0.0224 and the unit dm cube. So to convert this to centimeter cube, we multiply by 1000, and multiplying by 1000 we'll be having 22.4 centimeter cube. This will be serving as the final answer. So with this, we've come to the end of the solution of the question, and we've gotten the volume of carbon dioxide that will be obtained at s.t.p to be 22.4 centimeter cube. Don't forget to subscribe for more if you find this video helpful.